Have you ever looked at a circuit diagram and just thought, wow, that looks like a tangled plate of spaghetti? Yeah, you're not alone. But what if I told you there's a secret weapon, a tool that can take even the most complex-looking circuits and make them, well, simple? Stick around, because we're about to unlock the power of source transformation.
Okay, so let's be real. We've all been there. You're staring at a circuit with a bunch of different sources, resistors pointed in every direction, and you have no idea where to even start. It feels overwhelming, right? Don't worry, we're going to fix that.
I mean, take a look at this thing. This is a classic example of a problem that makes you want to just close the textbook and call it a day. But what if there was a way to sort of tame this beast? Make it play by your rules. That's exactly what we're here to do.
So really, what if you had a tool in your back pocket that could just snap its fingers and make this whole mess way simpler to deal with? Well, you do, and I'm going to show you exactly how it works.
So, what is this big secret to simplifying these circuits? It actually comes down to something we take for granted, the voltage and current sources that we draw. Turns out, they're not quite as perfect as they look on paper.
Just think about it for a second. If a real 9-volt battery were an ideal source, you could get infinite current just by shorting it out. But that doesn't happen, does it? Thankfully. Real sources have limits, and it's those very limits that we can use to our advantage.
And that brings us to the secret ingredient, something we call internal resistance. Now, it's not a physical resistor you can pull out of a battery. It's just a really clever way to model how a source behaves in the real world. It's what keeps things from, going up in smoke.
So how do we picture this internal resistance? It's pretty straightforward. For a voltage source, we just imagine a little resistor in series with it. That limits the current. For a current source, we put that resistor in parallel, and that limits the voltage. And right there, that's the key that unlocks everything.
All right, now for the main event. I like to call it the Great Swap. This is where we take those realistic models we just talked about and use them to completely transform our circuit into something way, way easier to handle.
Yep, you heard me right. We can literally take a voltage source and its series resistor and just swap it for an equivalent current source with a parallel resistor. And the best part, the rest of the circuit has no idea anything changed. It's like a magic trick, but it's pure, solid engineering.
And you know what's so cool about this magic trick? You don't need any advanced math. All you need is your good old friend, Ohm's Law. Seriously, if you know that V equals I times R, you've already got everything you need to master this.
Okay, so let's break it down. To swap out a voltage source, first you use Ohm's law to get the new current value. Then you just draw a current source where the voltage source was. Make sure the arrow points to where the positive terminal was. And finally, you take that series resistor and just slide it over so it's in parallel. Boom, done.
And going the other way, just as easy. To turn a current source back into a voltage source, you use Ohm's law to find the new voltage. Then you draw your voltage source so the positive terminal is where the arrow was pointing. And last, you take that parallel resistor and pop it right into series. See? It's almost elegant.
All right, enough theory. That's all well and good, but let's get our hands dirty. Let's see how this awesome tool can clean up a messy circuit in the real world and make our lives a whole lot easier.
Remember this monster from the beginning? Well, it's about to get tamed. This is a perfect example of a circuit that would be a total pain to solve normally, but with source transformation, it's going to be a walk in the park. Okay, so the first step is to spot a transformable pair. And look, right there on the left side, we've got a voltage source with a resistor in series. That's our target. So let's work our magic and swap it out for a current source with that resistor in parallel. And bam! Look at that, just like that. Our messy, complicated circuit is now a beautiful, simple parallel circuit. We've got two current sources we can combine, and all the resistors are in parallel. Analyzing this is so much easier. How great is that?
You know, the key thing to remember is what equivalent really means here. It means that from the perspective of everything outside the part we changed, nothing is different. The rest of the circuit behaves exactly the same way it did before. It doesn't even know we pulled a fast one.
But here's a quick pro tip, a little word of warning. While the external circuit doesn't care, the voltage and current inside the little piece we swapped have definitely changed. So if a problem asks you for the current through that specific resistor, you need to solve the simplified circuit first and then go back to the original to find that one specific value. Just keep that in mind.
So what's the bottom line here? We've just added an incredibly powerful new tool to our circuit-solving toolkit. And this isn't just some neat little trick. It's a total game changer for how you can approach tough problems.
So why does this matter so much? Well, for one, it lets you combine sources you couldn't combine before. It cleans up those messy series parallel circuits. And, maybe most importantly, it makes advanced techniques like nodal or mesh analysis way easier to set up. It's really a foundational tool for getting to the next level.
At the end of the day, source transformation teaches us a really valuable lesson. Sometimes the best way to tackle a hard problem is to just look at it from a different angle. It shows us that the rules we learn aren't really rigid rules. They're tools, and it's up to us to figure out the cleverest ways to use them. So go on, start swapping. Thanks for watching.